Welcome to an ARC Power User Conversation. And obviously, I'm Chris Pike. I'm your erstwhile host for this activity. And I am joined by Michael Murray. And we are going to talk about a sexy topic, utility data access. And so you might not think it's sexy, but we all know as ARC Power users that this is what drives ARC. ARC is powered by performance data. Performance data often comes from our utility, and getting our hands on it is one of the challenges that we all face. So we are here to talk with someone who is on the front line of this issue all across the United States. And I would like to introduce you to Michael Murray. And he is an old friend and an old hand in the commercial real estate world and in the utility world. And I would like to start by asking Tim to tell us a bit about his story, where he's been, how he got here, why he's putting his energy into this topic at this point in time. Michael.
Thank you, Chris. Great to chat with you again. So I began in an energy management startup company. I was co-founder and CEO of Lucid. And we made, at the time, was one of the first, this is 2005-ish, one of the first online dashboards for real-time energy usage in buildings. And it was web-based, and we brought in data from a bunch of different sensors, HVAC control systems in buildings, and it actually started when myself and my co-founders met at Oberlin College in Ohio. There was a very green building that was built there. As the story you may have heard is that energy usage in this building was 3 times higher than it was supposed to be. And everyone was wondering, well, why is that? And as is the case with a lot of buildings, there was HVAC problems and, different commissioning issues and so forth. So that sort of started us down this pathway where, to be honest, the traditional HVAC control vendors had really ignored the value of a more interactive and public display that would reach more audiences than just, say, the person in the boiler room. And around 2009, 2010, I got really interested in smart metering in utilities. So if you remember a decade ago, there was this euphoric moment when venture capital collided with electric smart meters that were going to be deployed nationwide, and it was going to bring forth this cornucopia of the incredible interactive appliances and home devices that would respond automatically to the conditions on the power grid. And there was this great optimism about the technology. Billions of dollars were spent on it. And essentially none of those really interesting features that would interact with the customer side of the meter and the electric grid, very few of them actually ever ended up happening. It was a big disappointment. And so I was living in California at the time, and I got this very expensive, it must have cost PG&E like $7 to print this multi-page color brochure. And it said, these are all the amazing things you're going to be able to do in the future at some distant, unstated time with your smart meter. And so I kind of scratched my head. I didn't know anything about how utilities worked. I didn't know what a public utility commission was. And I started asking, well, wait a second, my company can analyze this data and provide value. So let's have access to the data. Give it to me. I have customers in the Silicon Valley area. So we have the customer's permission. I went to the utility and I said, well, where's your API? Give me access to the information. And they said, well, we've thought about it. And if you really want access to this, you can have PDFs of the bill. And I was like, well, okay, that's a start, maybe, but wasn't the point and purpose of $5 billion spent on electric meters in the state of California intended to provide granular usage information to customers for energy analysis, the types of which I offer through my company? And they said, well, it's not really designed to do that. And so I got frustrated by this mismatch that I detected between sort of the public marketing of what these smart meters were supposed to do, and then the on-the-ground reality of, frankly, just how useless and ineffective they were. And I started picking at that. And essentially that sort of brings us to today, where I got involved with the Public Utility Commission in California. This was in the Obama administration when the green button efforts were starting up. We can talk about that a little bit later. But what happened was California issued the first ruling requiring, requiring utilities to implement this green button connect system, and that was back in 2013. And it was pretty exciting. It was there were so many companies. I think within 30 days of PG&E launching this, there were like 50 or 75 companies that registered to try to get access to usage data with their customers' permission. And that sort of launched eventually the nonprofit that I work at now, because I realized it's incredibly difficult to do this state by state by state. And we have this patchwork of utility regulation in the US, which is very complicated. And so my goal in life now, running this nonprofit, is to create a zero marginal cost, seamless data exchange environment, regardless of the zip code that you're in the US.
Wow, I love that journey. I love that passion about 5 billion doesn't get you what you think it used to. That is such an interesting story, and really, I really relate to it about sort of the foundational things that market transformation needs. The kind of granular data that you described. So that's awesome. Thank you for taking us back to go forward, and maybe with that in hand, maybe take us into mission data. Take us into what you do from here going forward.
Yeah, let's do it. So I'm sharing my screen now. We're a small nonprofit organization. Every year we get involved in about 10 different states. The federal government has some role, although it's a small role in getting better access to usage data. A lot of the heavy lifting happens at the state level. And so I put together this coalition with a couple of co-founders. There's about 30 companies that represents sort of the whole panoply of residential to commercial and industrial distributed energy resource companies, DERs. So this could be residential energy efficiency, it could be commercial industrial demand response, solar, everything in between. They all have this common problem of how do you get better access to your customers' data, either for giving a price quote for your product or service, or for monitoring and delivering that service on a continuous basis over time. And excuse me, we've made quite a bit of progress since 2014. I mentioned California was sort of the first state in this area with a policy in 2013. It was being discussed in states like Texas, and now we have about 36 million meters in 5 states in blue, where there's a mandate. There's a policy in place that says the utility has to make machine readable, electronic energy usage, and sometimes other billing and cost information available to customers and to third parties. And so I do a lot of, it's not particularly sexy, it's not particularly fun, but there's a quasi-judicial process at public utility commissions where I'm a witness, and it's sort of like civil litigation where you go in and you file testimony, and there's rebuttal testimony, and you file these briefs, and it's this is the nature of the Administrative Procedure Act. And maybe 2 years goes by, and then eventually, hopefully, you get a decision from that government agency that says, yes, here are the parameters under which we will provide data to our customers or the third parties authorized by customers.
So just to cast a mental image, this is exactly like CSI or one of those moments where you can't handle the truth type moments in court. And everyone should have that mental image in their head, right? Or no, a little different.
A little bit. I have been on the witness stand. I have jumped up and said, "Objection, Your Honor." So it's been known to happen.
Awesome.
I'm not a lawyer, but I play one on TV.
Great.
So here's a bit of background. So data portability is this global movement, and energy is a part of it, but it's just one sector. So it's important to understand, I think, some of these larger trends that are happening. So whether it's in social media information, if you want to take your photos out of Facebook and take them to another social network, there's this effort called the Data Transfer Project, which allows you to have more seamless exchange of your information, right? The idea is it's your information. It's not Facebook's information, it's yours. And you should have the ability to easily and seamlessly get it out of an incumbent provider and send it somewhere else. There's also a movement towards open banking in the UK, in Europe, and in Australia. These are standards for budgeting apps that could aggregate your information from 5 or 6 different financial institutions and roll it up into like a holistic dashboard of your personal financial health. Again, same principles, it's just different data. It's finance data instead of your Facebook photos and your Facebook posts. And we're also starting to see data portability with healthcare information as well, most notably with Apple's iOS. So there's now, I think in the US, several 100,000 clinics and hospital networks where you can get your health information into one place. And then eventually, the idea is that as you need to take that to other healthcare providers, you're sort of the central unit in control that you can decide, oh, I want a second opinion from this doctor or this specialist, and it'll be a lot much easier to exchange that information. So the overriding goal is actually better competition between services. So you shouldn't have just these data monopolies sitting on people's information, taking advantage of their position and making a worse customer experience. There should be innovation, and businesses should really have to earn their customers' business in a digital realm on the merits rather than simply incumbency. And so in the energy space, I just wanted to provide 4 different examples of what data portability is for. This is both residential and commercial. You could have smartphone apps for home energy management. These are things that would help you, in real time see, oh, energy usage is really high in my house right now. I wonder what's left on. How can I diagnose what's happening in my home? Batteries, so behind the meter resources that would help with commercial industrial peak demand charges. You need to know when to discharge that battery, when an upcoming peak energy usage period is beginning. That requires data portability, and ideally on a real-time basis. There's a new suite of voice assistants that are out there that are increasingly using data portability. So imagine asking, hey, Alexa, what's my utility bill going to be this month? Hey, Alexa, is my energy use higher than it should be? Give me tips for how to reduce that, right? This involves Alexa getting access to your usage and account and billing information at the utility. And then the last one, which will, I'm sure, be most familiar to this group, is portfolio level reporting, often on a monthly or on an annual basis, to Wall Street, to pension funds, to through GRES, Carbon Disclosure Project, et cetera, et cetera. And this is when I show this slide to utilities. Interestingly, they are shocked, they are surprised, they have very little idea that their large C&I customers need this information to report it to Wall Street. So a lot of utilities simply don't know, right? They're just the energy provider. They have a monopoly. They're not thinking about their customers' broader business. And they are shocked to hear that customers, especially the large C&I businesses, really need this information for reporting purposes.
It's such an interesting thing. Before you keep going for a second, I love the way you grounded the global movement for data transparency and portability. Is it fair to say that I think certainly consumer expectations, if not business expectations, are being set kind of outside of, for instance, the real estate industry? In other words,
yes.
our expectations for portability are coming. There's a bigger factor at play. Is that a fair take on?
Absolutely, and we see this all the time. This, you could call this the consumerization of B2B technologies. So people are increasingly frustrated. If you remember, in 2009, 2010, everyone was starting to get iPhones, but their businesses where they worked had a BlackBerry. Mm-hmm. And everyone said, well, why do I have to adapt? Why do I have to, as the employee, use what I think is an inferior, less desirable device? You make it work. You're the IT department. Let me use the device that I want. So the whole bring your own device idea. Again, great user interface, user experience that's set in a consumer area that then sort of runs upstream into businesses. And so you see, this was actually one of Lucid's successes. My startup was, we just had a really good user interface that people were familiar with from their consumer lives. That the expectations of how digital services should operate were set personally. They weren't set by the large building automation companies who wouldn't know a great user experience if it bit them on the ankles. So there's a big trend there, and this is the frustration that you see where people are like, well, wait a second, I can use Mint.com and get budgeting information from my retirement accounts, my car loan and auto loans, and my checking accounts, and et cetera, et cetera. Why is this so hard to do in the utility industry? And it's not hard. It's not a technical problem. It's a policy and political will type of problem.
It's so important. Thank you. Thank you for laying that out. It's really compelling.
So let me show you quickly what this would mean for you or for your users. Whether you're a residential customer or a commercial industrial customer, let's say you're sitting with an iPad, you're wondering, how can I save on my energy bill? How can I better share this information with ARC or with potentially an energy management app that's helping me with my West Coast buildings in the United States, for example? Well, you would be using, let's say, Acme Energy, and you would say, I'd like to access this service, and then you get a pop-up window where you would log in with your utility credentials, give them your username and password. If you don't have an account yet, you can go and create one, and then you get a screen like this in the middle, which everyone has seen before on a mobile device or on their desktop computer, and it says, would you like to share your data with Acme Energy? Allow or no thanks if you don't want to do it. You have a chance to read their privacy policy and so forth. And you click yes, and then immediately you have access to these data analysis products. So for example, using some analysis of your trends in energy usage, this would give you an itemized savings, in ascending order of if you switched to, a heat pump furnace as opposed to using a gas furnace. You could even sign up for alerts via text message. This was used in the summer in California. You may have heard about the blackouts that happened last August. Well, consumers were getting through a really innovative, creative app. They're called OhmConnect. They're members of Mission Data. You would get a text message that would say, hey, this is a hashtag Ohm hour. Please save energy use from 4 p.m. to 5 p.m. and you can win prizes and gift cards and so on. They turned it into a game and delivered several hundred megawatts of load reduction to the California grid, which literally helped keep the lights on for millions of Americans during that blackout. So this uses sort of standard off-the-shelf technology. Green button is one of the standards for exchanging the usage data, but the same technology for granting an authorization is OAuth. That's what PayPal and Google and Microsoft and a lot of big tech companies are using today. So again, existing building blocks of the technology. It's not that difficult to implement, but it is hard to get it done consistently and universally across the roughly 3,500 retail electric utilities we have in the US today. So you had asked me earlier, Chris, about what are some of the new things that are happening in the Biden administration. I feel sort of compelled to at least mention a couple of these. We'll end my presentation with a discussion of some of the states specifically and how some of the users can get involved, but it's worth mentioning briefly what's sort of happening at the federal level. There's a few different levers that the new administration can pull. One of them is through the Federal Trade Commission, and they've been working on data portability economy-wide. This is using the FTC's authority under the Unfair and Deceptive Trade Practices a set of laws, the Federal Trade Commission Act. And it's really an interesting area. They're thinking about banking and healthcare and social media information. It's really an economy-wide effort. And actually, just yesterday they announced some new rulemaking authority that they will try to use to address some of these topics. We have yet to see how much it will involve the energy sector, but it's a pretty good move on the FTC's part. In the middle here is green button. We'd love to see greater government support in the standards development area around green button to just help the standard mature over time. So we have, like I said, 36 million meters now that have a mandate for green button, but well, you know how it is. Software needs to be constantly improved for it to stay relevant and useful. So we'd like to see more federal involvement through the Department of Energy and the National Institutes of Standards and Technology. And then finally, the CLEAN project. For those of you who may not be familiar with it, it's a database of, I think it's over 200 or 300 clean energy policy ideas that a number of folks put together for the incoming administration. And some of our ideas on data portability in the electric utility and gas utility sector were highlighted as some of their one of their top projects, top policy ideas to give to the new administration. So we'll see what they do with that. And then finally, there's been two pieces of legislation in Congress that address this. They were not passed, but they may come back in an infrastructure package now that Biden's initial COVID relief bill has passed. The first one is called e-access, and that would establish essentially voluntary guidelines that states could adopt. So it helps provide a little bit of a push, but again, it's not mandatory. The e-no bill, which was originally from Senator Udall a few years back, would actually make data portability among utilities required, mandatory under PURPA. And so it'd be machine readable energy usage and cost information. And we don't know for certain. I don't have any crystal balls into how Congress operates, but these are two ideas that that are definitely being discussed because they could help move Biden's clean energy agenda forward.
Like one quick question on the last part of that on the side is, do you clearly evolving since that was first introduced was the desire to have closer to real-time information about emissions and the impacts of the grid, not just the cost and the usage information. Do you see those threads coming together, or do you think that, because we obviously are seeing that information beginning to be available, but is yet again highly fragmented? What are you seeing on that?
Yes, definitely. It's so that this segues into the next thing I'm going to talk about, which is you need to marry real-time energy usage information with real-time emissions and cost information.
Mm-hmm.
And as more and more retail rates in electricity move towards having a time-varying component, you really need a system for broadcasting what those rates are at any moment. Some people may have heard about in Texas, right, where the some people were exposed to the real-time price when that the storm came in February. And people needed to be able to respond to that in real time. And California is actually working on some very interesting standards that would broadcast through the internet and actually using a digital sort of sub-frequency within the FM radio broadcast, a real-time price to your water heater. So you wouldn't need an internet-connected water heater. You could just have a little radio receiver that adds just a tiny little, cost to your electric water heater, and that would respond and optimize and allow more renewables to be put on the grid in California. So there's a lot of really interesting stuff on the cost and the emissions side that are happening. WattTime is a member of ours, and they're part of Rocky Mountain Institute now. They have an API for broadcasting 5-minute emissions intensity of electricity. So that's great. They support a number of grid regions throughout the US. But again, for that information to be actionable, you need the real-time usage data, right, to be multiplied by kilograms of CO2 per kilowatt hour, as that varies over time. And then the product is actually actionable information that you can do something with.
So interesting. Only one quick thing we can comment before you jump in is saying that's a functionality, the ability to absorb minute by minute, even second by second emissions data is actually latent within ARC. We have had trouble generalizing it because the data from each provider is so heterogeneous. So it actually is possible to stipulate. Actually, you can do it manually if you cared to, but you could do 8760, you could do whatever. But the problem with making it general is that the data is not well structured. So it's very difficult. Each provider creates it. So our problem is not conceptual, and it's not even technical.
Right. It's just there's too many of them, and that's why WattTime is great, because they have an API for, I think, the vast majority of the United States. There are companies that, like Utility API, that are working to standardize the usage data as sort of like an integration layer on top of all the 3,500 electric utilities in the US. So all of those things are really, really important. But this is, again, we need not only the development of standards, but we need adherence to the standards. So It's one thing for NIST to invent a great standard in the lab in Gaithersburg, Maryland. Love it. That's really important. But now it has to be with fidelity implemented by every, provider of that information, be it a grid operator, distribution utility, what have you. So that's really the challenge.
Totally get it. Awesome.
So a couple of different ways of accessing your usage data that your users should be familiar with. So green button connect, that's the first one. That's generally 15-minute or sometimes hourly information that's sent back to the utility. There's some time lag associated with that, generally 24 hours. But that's the type of information you get. This is usually what commercial customers are billed on. So very useful information, but it's not real time and it's not highly granular. Number two is the home area network. And beginning 10 years ago, we started installing utility meters that have a Zigbee radio in them. And now it's going to be moving towards Wi-Fi. So you have the potential, at least, for connecting your meter to the Wi-Fi network in the building and sending out 1 minute or 1 second or 5-second data to any URL of your choice. So that could be to an energy management system, what have you. Maybe ARC, would be more interested in the green button connect type of information because you don't need the, super granular 1 second information. But for some operational decisions, it's really helpful to have real time, particularly if you need to curtail your load because of a peak demand period that you're coming up against or something like that. And then finally, there's distributed intelligence. And let me just spend a minute talking about that. This is a new capability that is putting a computer into smart meters. And we're starting to see deployments now in Colorado, Minnesota, New York, and a few other places. And what this does is instead of getting this sort of very coarse picture of energy usage in your facility, you can get extremely granular. And what I mean is one measurement every 10,000th of a second, or potentially even more granular than that. And so you get very detailed power, voltage, and current information, which you can use to disaggregate into the home or the building. Where's that power being used? So for example, on the right, you can see this is a commonly used graph in research on disaggregation in the residential sector. You can look at things like, when equipment turns on and it looks like it has a compressor cycle and it has a certain, cycling and duration. Well, that looks like a refrigerator. This big one that jumps on but only runs for 20, 30 minutes, that's probably your oven. And so imagine being able to have this fine level of detail in a home or a building. So you could detect things like, I have both a heating element and my compressor for my refrigeration are running at the same time. Let me send a text alert to the facility manager to take a look at that. So this is excellent capability that's in these meters. And what we're hearing is that these meters are essentially now at cost parity with traditional electric utility meters. And so we're just going to start to see millions of these being deployed over the next 5 years or so across the US as the major manufacturers incorporate essentially a Linux computer inside every meter under the glass. And then last thing is, these are some of the states where mission data is active. And so if your users have facilities in these states that I've highlighted on the left, particularly upstate New York, Ohio, New Jersey has a big rollout of these DI capable or distributed intelligence capable meters. We're also looking at data access policies around green button in states like Michigan and also Minnesota. So if your members have facilities here, please contact me. Here's my email address. I'd love to keep in touch. Like I said at the very beginning, there are utilities, frankly, most of them that I've spoken with, who have no idea that there are building owners who want and need access to information, who are trying to run analytics. And my fear is that we waste a lot of taxpayer and ratepayer money on meters where the functionality isn't being utilized.
Oh, Michael, it's such a compelling story. I'm so glad that you were able to share it with us. I mean, why don't in the spirit of, we want to respect everyone's time, keep everything tight, but I'd love to have you crystal ball this a little bit. We're at a pivotal moment. Some of the things that you described as advances, whether we're embedding edge computing into our meters, whether we have enabling policy. If you were advising or informing folks about how to anticipate the next 3 to 5 years in this domain, maybe a way to bracket. what's an optimistic case? What's a pessimistic case for where we could be with utility data access in the next 3 to 5?
Great question. The optimistic case would look something like this: commercial building owners and residential customers pursuing solar, battery storage, for resiliency in the face of power outages on both coasts, and the Gulf Coast. They are going to be driving the demand for greater access to data. And in turn, those distributed energy resource providers, the solar and battery installers, the energy efficiency firms for buildings, are going to be going to the utilities saying, please give me this information in a standardized way. So I think that can lead to a positive feedback loop where the more DER businesses that are putting pressure on the utilities, then the utilities start to standardize, starts to become a little bit easier, and then it becomes that much simpler for the next DER company to start up and start innovating and providing a service. Right now, we're in a situation where the utilities kind of say, well, we don't have any, we've never experienced interest. No one wants any of this data. And so why would we spend any money of ratepayer money serving you? It just doesn't make sense. And that's what I pull my hair out when they say that, because I'm like, there are thousands of facilities that want better information. And, you're just a dinosaur monopoly that has its head in the sand and you're not getting with the program. So the optimistic case would be in probably maybe a third to a half of the United States, we could have true seamless data portability for all residential and commercial customers. If you have a giant building in Detroit, or you just want to ask, hey, Google, what's my energy usage right now? It would all work seamlessly in about 50% of the US in 5 years. The pessimistic case is that utilities continue to act anti-competitively. They're sort of afraid of a distributed energy future when they're relegated to becoming dumb wires companies, and they lose some of their political power and potency. And so if they try to separate the market and make it extremely difficult for companies to operate, they kind of take the oxygen out, and it will be very hard for some of these companies to succeed. I am somewhat dubious that that's going to be long-term successful, because increasingly companies are doing things like they're providing their username and password to their utility account, and they're giving it to their energy provider saying, hey, just help me manage this. And then a bot impersonates them, uses their username and password, logs into their utility website, and gets all the information that they need. So utilities can put up some sort of barriers to that, but the long-term tidal wave is coming, and I think they have a choice. They can either get with the program and adopt standards and help facilitate customers' needs as they evolve, or they can just continue to put their feet in the ground and sort of lose relevance as the industry essentially works around them more and more.
Oh, that's a really powerful place to leave it. I mean, I hope what our ARC users and our other stakeholders take from your remarks is, you have identified this foundational issue, and you're out there fighting what is a really hard fight. and I hope we'll learn more about what you guys are doing. I'm thinking back to your remarks. I'm happy that you weren't satisfied with that PDF that they offered you. I mean, because this is one of those fights that whether people realize that realize that they need it, or realize that you're doing it, it is the infrastructure that we're going to need to power a performance-based future. So that is incredibly compelling. So thank you. I want to thank you. I can keep talking to you all day, but I think the respect for it, you left it in a great spot. So I want to encourage people who are listening to check out the Mission Data website, learn more about what Michael's doing, and think about how it enables what we're trying to do with ARC. And so I want to thank you for your time.